Hi, guys. Thank you very much. Cheers, man. Right. Well, I can't tell you how excited I am to be here speaking alongside all these amazing speakers, and Mark's fantastic as well. What a fantastic event organizer. I mean, he's absolutely excellent. So I'm going to talk to you today about security, which I think is one of the more important issues that we face at the moment. And a lot of people don't really understand much about it because they think it's too hard or it's just, quite frankly, boring. So hopefully I'm going to try and delve into this a bit, demystify it, and just scare you all a bit into actually pulling your finger out and sorting it out. So, I am from the UK. I run a digital agency called Parallax. We make websites and shit. You can ask me about that later. I also write a JavaScript library which generates portable document files in client-side JavaScript. So it generates like binary data URIs and stuff, so you can use it for event ticketing, stuff like that. Okay, so security is everyone's problem. What do I mean by that? Well, if you're a website author, it's your responsibility to protect your users and understand the risks that they may face. If you are a user of the internet, it's your responsibility to protect your own data. So if you're using public Wi-Fi, you should be using a VPN, that kind of thing. So I think it was, has anyone heard of DEBOOKEE for Mac? No one? Okay. So I came across this software probably about 8-9 months ago. Me and my colleague were debugging a network issue between 2 points. And we came across this. So we fired it up, we picked the target device and the other device, and we pressed go, and it showed us all the communications between those two devices on the network. And I was like, what the fuck, how does this work? Like, I haven't set anything special up. This is what I thought was a secure Wi-Fi connection in our offices. How does this even work? And it's that moment where you learn just one more thing about something, and then you realize that you know absolutely nothing at all about it. So this is DEBOOKEE. Download it. If you think you're going to use it for bad stuff, don't download it. So you press scan, you choose your targets, multiple targets. This will even list the names of the people whose iPhones and Androids are using something called MDNS, which is pretty cool. Press toggle target, then you press start, and you can see all the network traffic. So HTTP, DNS, you can see what sites they're visiting, you can see what SIP calls they're making. This, if you go home and you download this, it will absolutely freak you out. So the only saving grace, really, is that you can only see the full URL for the HTTP addresses. You can't see it for the HTTPS, but you can see the domain name. But on HTTP, if you right-click on one of these sites, click Copy Headers, copy the cookie from the header, you can actually put that into your browser and log in as if you were them. It's pretty fucking dangerous. So I actually, I actually did this to my colleague. So he was logging into our intranet, our secure intranet, over the Wi-Fi. And because he already had a session set up, I nicked his session cookie, logged in as him, and just posted a status, I love James. And he was like, fuck, this is really bad. So you might think that this is not so much of a problem because people have to be on the same Wi-Fi network as you to actually look at the network communications that are going on. Well, no, you're actually quite fucked because it's really easy to actually crack into a Wi-Fi network. So you'll need a really expensive, specialized piece of gear. This is a £30 Wi-Fi dongle, and this can be put into passive mode and just listen to the packets going over the air. All you need to do is pull out something called a handshake packet, which is when a computer connects to the Wi-Fi. Initially, it does a little handshake. Once you've got that packet, you upload it to a site like Cloudcracker. That will try billions of combinations of common passwords, and this is based on passwords that they've seen out in the wild. So if you do stuff like replace an I with an exclamation mark or add a 2 on the end, it'll get all that shit. So make your passwords really nice and long. Use phrases, use spaces, use punctuation. Use things like sentences are easier for humans to remember, but hard for computers to guess. whereas the short, lots of symbols and all that sort of stuff that we tend to use, that's actually really simple for computers to guess, but hard for humans to remember. So make your passwords really long. So how do we fix this? Well, in case of the Wi-Fi passwords, just make them long. But for the rest of it, we actually need to use SSL. How does SSL work? Yeah, sorry. If you use websites, you should be using a VPN. That will protect you from this attack. So, yeah, what is cryptography? So, cryptography literally means secret writing. And it's what we're going to do is, because there's no Wi-Fi, I'm going to do a sort of offline demo of intercepting, well, how SSL works. So, John and Tim, do you want to come up? Do you want to come up as well? Cool. This might not go to plan. So yesterday I got to the conference and like, oh, there's no Wi-Fi. I thought, fuck, I'm going to have to go out and buy some props. So I went to the supermarket. I found this. This is called Ajax. I was like, I need to work this into my talk somehow, but I can't figure out how it's going to fit in. So, oops. 1 second. You might be up there. Thank you very much.
Use some more tape.
Just stick it all the way around my head like that. Okay, so you guys are going to send each other a message, but it's going to be in an envelope, and I'm going to use Post-its and stuff like that.
Oh,
so
right, okay.
You're going to be the sender. You look more like a receiver to me, so you go this end. Hang on a sec. So, John, if you want to stand over this end.
We call them takers.
Yeah, takers. Right, 1 sec. Don't know why the fuck I thought to use props on one of my first big talks, but there we go. Right. John, if you want to write a message on this, nice and big, nothing too rude.
On the outside of the envelope?
On the outside, yeah. Right. I've got no idea whether this will come off well, and I'm having a few audio problems, but I've got some Post-its here with some keys and locks on. So if you want to take a key and a lock. John, if you want to do the same.
What am I doing? Taking a key?
Key and a lock. Don't worry, I'll buy you a beer later.
You will.
Oh, cheers. I should have had a haircut. I think that's what the problem is. It's sort of interfering. Cool. If you want to stick that in the envelope. So, John's the sender. You're the receiver. I'm the unsecure, untrusted transport. So you don't trust me because I'm going to fucking look at this. Right? So what you first might try and do is stick a lock on it. And then send it across the untrusted transport. And then what you might try and do is send a key across afterwards. That's not going to work, because I'd be able to intercept the key and unlock the message. So what actually has to happen is you put your lock on, and then it goes over the internet. You put your lock on, back across. You take your lock off, and then one more time, and you take your look off. And at no point can you see what the message is. This is a similar way to the way the maths works. Some crypto geeks will be like, no, that's not exactly how it works. Shut up. It's close enough. Right, thanks very much, guys. That's it, yeah. Thanks.
So you don't know what the message is?
Oh, yeah, I don't know what the message is. It says, btconf rocks. Sweet. Right. Is it too early to drink? In Germany, exactly. So, on the internet, we don't actually have locks as such. We have ciphers. Who's familiar with how ciphers work? There's a few. Okay. So one of the earliest ciphers was the Caesar cipher. You'll have seen this before. You'll have used it at school, or like, you know, you get those little spy wheels that you turn around. So each character maps to another character with a shift. The shift's called the shift value, and you just basically pick a number, and it encodes it. This is obviously very weak, because you can do stuff like you can count the number of E's, and every language has got its own profile of what the most common letters are, and you can instantly figure out what the shift is. There's another type of cipher called a one-time pad. This is a very secure kind of cipher, so your key space is the same size as your input. So this is kind of like the Caesar cipher, but individual to each letter. This is very secure because it's impossible. It doesn't leak any information in the output, but it means that you have to share this key somehow. And then there's another kind of cipher called a stream cipher, which is what SSL uses, where you have a key, which is your random seed number, a key stream, which is your random number generator, chucks out numbers based on the key seed, and then input, output. That's kind of how SSL works in a nutshell. But how do we get the shared secret? So this is a real problem. So banks used to have networks in place across the world before the internet existed, and they sent secure information across it. But what they did was they actually flew with a briefcase full of the keys, because they didn't have a way to transfer securely the keys over the internet. So how do we get this shared secret then? Does anybody know how this works? This is called the Diffie-Hellman key exchange. So Stefan wants to send a message to Mark. We're going to use colors in this example instead of numbers. So Stefan picks yellow, sends it to Mark. Eve is the eavesdropper. And she can see the color that's gone over the wire. They each then pick their own secret color that they don't share with anyone. So Stefan will never give this red over the wire. Mark will never give this blue over the wire. They then mix the private color into the public color. And then they share that mixed color across the network. Eve has a copy of the mixed color. And then finally, the final part of the trick is they mix their private color into the mixed color that was sent over. And they end up with the same color. This actually works with paint. You can do this. But we don't have colors in cryptography. Instead of colors, we have prime numbers. And instead of mixing paint, we have what's called a one-way function. So if you imagine mixing two colors of paint together, you know that it's almost impossible to reverse that and get to the two colors that were the input. That's what this is mathematically. Easy one way, hard the other. So we're mixing 29 and 17 to get 12, but it's impossible for us, without trial and error, to arrive at the number 29 without going through every single iteration. And we don't use primes as small as this. We use really big primes. Like, this is my favorite prime number. I think this is really cool. Just look at it. So that, in a nutshell, is how SSL works. And that's how we fix man-in-the-middle attacks. So that's one problem solved. So next up, I'm going to give you another problem. So earlier you learned how to make icons with SVG. Now I'm going to show you how to hack websites with SVG. So, yeah, it could be good. So it's called a timing attack. Has anyone used a request animation frame before? You use it for like animating stuff. What it actually does is it exposes how the underlying hardware is working in a strange sort of way. So if you were to insert the site you want to attack in an iframe, and then use some CSS to move it just off screen, then cut it down so it's 1 pixel in size, and then if you were to devise a filter that took longer on a black pixel than a white pixel, you can actually read the pixel out of the iframe from the remote site. This is regardless of whether it's using SSL or anything else. And this is a white paper's just come out recently that does just that. But it gets worse, because you can, in Google Chrome, you can actually iframe the view source URL, which means you can build a really crude OCR tool to read the characters out of the source itself. You can even jump to the line that you want to attack. So you'd be able to get this cross-site request forgery token and actually perform cross-site request forgery. How mental is that? So how do you fix it? Easy. Just set a header. The browser will protect you. Just disallow people iframing your content. It's as easy as that. Okay. Now, I was going to do this live, but I'm not going to. So, you know when you hop onto the internet in a hotel or on Wi-Fi and you get redirected to a page like this? This actually uses the same method that my attack uses to remove SSL encryption. So, the first request to a site is always over HTTP. And then you get a response that says, hey, look, you should probably go over HTTPS here. So I built a tool that actually ignores the HTTP request coming back, rewrites it so it just basically does string replace, passes it on to the end user, and acts as an invisible gateway. So the end user has an unsecured connection to you, and you have a secured connection with Google or whoever it is. Google doesn't know that you're not the end recipient of that content. So I built a scary app to demo this, because I showed my girlfriend the DEBOOKEE thing, and she was like, it's just like log files, I don't get it. So I built this app. It uses SSL strip, which removes SSL. It uses ARP spoof, which is what you use to pretend to be the router, which tricks the network into sending you its packets. It uses WebSockets. It uses Node.js, all the buzzwords. It uses CSS3 3D transforms, because why not? It uses lasers. Yeah. Doesn't use lasers. Doesn't use lasers, sorry. Okay, this is it. So this is me visiting a secure website on my mobile, and it actually renders the content that is visible on the display on this 3D iPhone. And it also takes the gyroscope data, which you can access without any warnings or pop-ups or anything like that. So this was the demo that got my girlfriend to say, fuck, this is bad, isn't it? So yeah, I logged into my bank. I even had it unmask the password, so as I typed it, I could see it on the screen coming up. It's really scary. Okay. The problem is, with the SSL strip, is it removes the lock from the address bar. So I thought, well, I know I can get a lock up there. What about a favicon? Stick a favicon in there, why not? That'll do it. That might trick a few people, I don't know. So to fix this one, you use something called HTTP Strict Transport Security. Try to say that 3 times fast. And this basically says, always remember to access me over SSL. And you set a time limit. So this is one from PayPal.com, and they say 2 years. So if you visit PayPal.com on a device before you enter a hacked network, you'll be protected. So I recommend you do this straight away. This is how you do it in Ruby. This is how you do it if you're unfortunate to be using PHP. Okay, quick recap. Problem, HTTP sucks. Solution, use SSL, or if you're a user, use a VPN. Next problem is iframes suck. That's easy as well, just set a header. And SSL sucks too, so use HSTS headers. And that's basically it. Thank you very much.